Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Thanks, Chris, and I'm genuinely fired up about today's story because for once, it is not about a flashy new model or a giant funding round. It is about plumbing.
Plumbing is an interesting way to tease it, so before everyone tunes out thinking we have gone boring on them, tell me what you actually mean by that.
I mean the physical guts of the internet. The headline this week is that Microsoft, one of the richest companies on Earth, had to borrow capacity from its single biggest cloud rival just to keep GitHub from falling over.
Okay, now that is a hook, because GitHub is Microsoft's crown jewel for developers. Walk me through what happened, because borrowing from a rival sounds almost embarrassing for a company at that scale.
So on June 16, 2026, Microsoft confirmed it has been routing GitHub traffic through Amazon Web Services. Their own spokesperson said the spike in agentic development that began late last year has tested their infrastructure limits.
Wait, let me make sure I have this right. Microsoft is paying Amazon, the company it competes with most fiercely in the cloud, to keep its flagship developer platform online. That is the situation we are describing here.
That is exactly the situation, and the irony is delicious. Microsoft bought GitHub back in 2018 for $7.5 billion, and the whole strategic point was to funnel developers onto Microsoft's own Azure cloud.
So the on-ramp to Azure has gotten so congested that they have to detour traffic onto Amazon's highway instead. What pushed it over the edge, because GitHub has handled enormous load for years without this kind of crisis?
One word, and it is the word of 2026, agents. AI coding agents do not work like human developers. They run continuously, in parallel, across many repositories, around the clock, never sleeping, never taking a coffee break.
That is a really important distinction. So help the audience feel the scale here. How much extra load are these autonomous agents actually generating compared to what a normal human developer workflow would have produced in the past?
The numbers are wild. GitHub's chief operating officer Kyle Daigle confirmed in April that the platform was processing 275 million commits per week, on pace for 14 billion this year, up from 1 billion in all of 2025.
Hold on. 14 billion this year versus 1 billion last year? That is a 14-fold jump in a single calendar year. No infrastructure team on the planet plans capacity assuming their load will multiply by 14 in 12 months.
Exactly, and it gets sharper when you isolate the agent activity specifically. AI agent opened pull requests jumped from 4 million in September of 2025 to more than 17 million by March of 2026. That is fourfold in 6 months.
So the agents are not just adding to the human load, they are becoming the dominant source of traffic. What did that actually do to the service that real developers experience when they sit down to work each day?
It broke it. GitHub logged 9 service degrading incidents in May alone, and availability dropped to roughly 88.4% in June. For context, the enterprise promise these customers pay for is 99.9% uptime.
88% might not sound catastrophic to a casual listener, but in infrastructure terms, that gap is enormous. Translate that for me, because the difference between 99.9 and 88 is not a rounding error at all.
It is the difference between a few minutes of downtime a month and hours of downtime every single day. HashiCorp co-founder Mitchell Hashimoto put it bluntly on X, saying GitHub was no longer a place for serious work.
That is a brutal quote coming from someone of his stature in the developer community. Because when your most sophisticated power users start publicly questioning whether your platform is usable, that is an existential reputation problem, not a minor hiccup.
Right, and here's the part that elevates this from a GitHub story to an industry story. Microsoft is not alone. Google, which runs one of the largest cloud networks on Earth, is in almost the exact same bind.
Now that surprises me even more than the Microsoft news, because Google designs its own custom chips and operates some of the most sophisticated data centers anywhere. How could Google possibly be running short on compute capacity right now?
Because demand is outrunning everyone. A deal surfaced this week showing Google agreed to pay SpaceX $920 million per month for compute at xAI's Colossus data center, running from October of 2026 through June of 2029.
Let me just sit with that figure for a second. $920 million a month is more than $11 billion a year, and Google is paying that to access a competitor's data center. That is staggering.
And Google's own framing is the tell. They called it bridge capacity to meet demand for their Gemini enterprise platform that was, in their words, even higher than we expected. Even Google did not see this surge coming in time.
So we have Microsoft leaning on Amazon and Google leaning on SpaceX. It is starting to feel less like isolated incidents and more like a structural pattern where nobody can build fast enough. Is that the right way to read it?
That is precisely the right read, and Anthropic is in the same boat, paying SpaceX $1.25 billion per month for the Colossus One facility. The biggest names in AI are all renting from each other now.
That cross-renting dynamic is fascinating because it suggests the competitive walls between these giants matter less than the raw scarcity of compute. When you are desperate for capacity, apparently you will buy it from anyone who has spare racks available.
Exactly, and the scarcity is layered, which is why money alone cannot fix it overnight. Physical data center construction takes 18 to 36 months from picking a site to actually running workloads. You cannot just wish a building into existence.
And it is not only the buildings, right? My understanding is that the power demands of these AI systems are fundamentally different from the cloud computing we have run for the last decade. Can you unpack the energy side of this?
Absolutely. A high-density AI rack draws somewhere between 40 and 100 kilowatts, compared to 10 to 15 kilowatts for conventional cloud computing. That requires utility-scale power upgrades that take years and trigger fights with local regulators and ratepayers.
So the bottleneck is not just chips. It is concrete. It is transformers. It is transmission lines. It is the literal electrical grid. That is a much harder problem than writing a check, because you cannot accelerate pouring concrete with venture funding.
You really cannot, and the chip layer is constrained too. Reports say NVIDIA's Trainium chips at Amazon are sold out through 2028, and Oracle is sitting on a $638 billion backlog of committed infrastructure it is racing to build.
Those numbers are almost hard to comprehend, so let me ask the obvious skeptical question. Is this just a temporary growing pain that smooths out in a year, or are we looking at a genuine multi-year structural ceiling on AI growth?
The most sobering data point suggests the latter. Goldman Sachs estimates the world will need $7.6 trillion in cumulative AI capital spending from 2026 through 2031. That is roughly a quarter of annual United States economic output.
A quarter of U.S. economic output devoted to AI infrastructure over 5 years is the kind of number that reframes the entire conversation. That is not a tech trend anymore. That is a civilization-scale industrial build-out on the order of railroads.
That is a perfect analogy, and like the railroads, there will be booms, busts, and stranded assets along the way. But the demand signal right now is so strong that even the cloud giants are managing it through emergency measures.
Let me push back a little, though, because I want to be fair to the other side. Could some of this just be poor planning by these companies rather than a true industry-wide ceiling that nobody could have foreseen?
It is a fair challenge, and partly yes. GitHub's leadership admitted back in October of 2025 that they had already breached their uptime commitment and started a plan to expand capacity tenfold, so the warning signs were visible.
So they saw it coming and still got overrun, which honestly makes the story scarier, not more reassuring. If a tenfold expansion plan was not enough to keep pace, then the demand curve is steeper than even insiders modeled.
Right, and that is the heart of it. The agent economy introduced a demand profile that capacity planning simply did not anticipate, because the planning assumed human developers bound by human working hours, not tireless software agents firing requests continuously.
That reframes how I think about the whole agentic AI movement, because we usually talk about agents in terms of productivity and capability. We rarely talk about the brutal infrastructure tax that all those autonomous actions quietly impose behind the scenes.
And GitHub is already responding to that tax. Back in April, they moved Copilot plans to usage-based billing, replacing flat request units with credits calculated from token consumption, which is both a revenue mechanism and a way to throttle runaway demand.
That makes sense as a pressure valve because metered pricing forces users to internalize the cost of all those agent actions. But it also signals the end of the all-you-can-eat era that developers got comfortable with over the past few years.
It really does, and that leads to 2 practical takeaways I want listeners to walk away with. First, do not expect AI model pricing to fall meaningfully over the next 12 to 18 months because the cost structure is under rising pressure.
That cuts against the popular assumption that AI gets cheaper every quarter, like consumer electronics did. You are saying the underlying scarcity could actually keep prices sticky or even push them up, at least until the capacity finally catches up.
Exactly. And the second takeaway is about reliability. The public incident reports from providers probably understate the stress on these systems. GitHub at 88% availability is just the most visible crack in an industry quietly straining under peak load everywhere.
So if you are an enterprise team betting your operations on a single AI provider, this week is a flashing warning light to build in redundancy and not assume the capacity you were promised will always reliably be there.
That is the smart conclusion, and it ties back to a theme we keep circling on this show, which is that resilience and optionality matter more than ever when the entire industry is operating at the absolute edge of its limits.
Before we wrap, give me your one-sentence prediction. Where does this capacity crunch stand a year from now, when we look back at this June from the vantage point of next summer and ask whether it eased or worsened?
My prediction is that the crunch eases at the very top tier as new data centers finally come online, but the second-tier providers in the power grid stay the binding constraint well into 2027 and possibly beyond that.
That feels right to me, and it is a humbling reminder that even in an industry obsessed with software and intelligence, the ultimate limits are stubbornly physical. Steel, silicon, and electricity still set the pace for everything we are building.
Beautifully put, and it is why I think infrastructure is going to be the defining storyline of the back half of this year, even more than the model releases that usually grab all the headlines and all the attention.
That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.